Hi, my name is Ross Heidersbach, and I am a mechanical engineering student here at Ohio State University. Today, I will be reviewing the final project for one of my courses known as ME 2900 Intro to Mechanical Engineering Design. The final project, or the goal of the final project, was to automate some mechanical tasks using a Arduino microcontroller. For my specific project, I decided to automate the deployment of flaps on an aircraft using a pitot tube, a pressure sensor, a couple of flaps, an RC plane, and the microcontroller. For those of you who are not familiar with aircraft or are not well versed in the technical side of aircraft, flaps are high lift devices used on airplanes for low speed flight. They usually produce a little bit of extra lift, which is good for low speeds. So if you look outside of an aircraft's window during takeoff or landing, you can see at the trailing edge of the wing that there's a little surface that kind of bends down during takeoff and landing. Those are the flaps. And like I said before, they produce a little bit of extra lift. So usually pilots determine the flap setting, or how many degrees of flaps they want to deploy on their aircraft by the airspeed that they're flying at. And generally, the slower you go, the more flaps you want. So if you are flying at 90 miles an hour in a Piper Arrow, for example, you want like 10 degrees of flaps. But if you're going about 75 miles an hour in that same aircraft and you decelerate a bit, you want 40 degrees of flaps. So as you can see, the slower you get, the more flaps you want. If you do a little bit of research, you can determine that a lot of airplane crashes happen during takeoff and landing of a commercial flight. You could also do a little bit more research and determine that pilot error is a major factor in these crashes. And if you kind of think about it a little bit, a lot of things are going on during the takeoff and landing phase of a flight. You know, pilots have to communicate with air traffic controllers, they have to navigate, they got to monitor a lot of different systems in the aircraft. So it's really easy to get a little behind the aircraft and kind of neglect some certain duties. So I wanted to kind of ease up on their burden by automating the deployment of flaps. So what I did is I used a Arduino microcontroller, pressure sensor, and a pitot tube to measure the airspeed that the aircraft is flying at. The pitot tube and pressure sensor measure a thing called dynamic pressure, and dynamic pressure is really similar to like sticking your hand outside of a window of a car going down the highway and your hand being pushed back. So what happens is the pressure sensor senses this pressure. It produces an analog signal and sends it to the Arduino microcontroller. In turn, that analog signal corresponds to a certain voltage, and based off of the data sheet for the pressure sensor that I have, you can convert the voltage to a dynamic pressure. And you could look up a formula that converts dynamic pressure to airspeed, and that formula is dynamic pressure is equal to 1/2 air density velocity squared. For this project, I assumed that air density was standard at 1.225 kilograms per meter cubed, and I rearranged the formula algebraically to solve for velocity. And Arduino calculates that and compares it to preset values that I programmed into the microcontroller. For example, if the aircraft is operating between 45 miles an hour and 60 miles an hour, the microcontroller tells two servos to lower the flaps to roughly 10 degrees. If the aircraft is flying between 30 and 45 miles an hour, the flaps go down to a second stage, which is roughly 20 degrees. And if the aircraft is flying even slower, then it just goes to 30 degrees of flaps, which is the third and final stage. Alternatively, the aircraft goes above 60 miles an hour, I should say. The flaps go to a neutral position. And if the aircraft is actually going too fast, which I programmed as 90 miles an hour, the flaps actually go up and act as a speed brake to prevent like an overspeed scenario, kind of. So I will show you the product now, which is actually behind me. Okay, so behind me is actually the prototype, and let me get it here. It is a stock, well, not stock anymore, I should say. It is a modified Parkzone T-28 Trojan. If you look at it, kind of see the flaps here and here, and that is the surface that we're controlling with the Arduino microcontroller. If we look at the back side of the wing, you can see I had to cut out this little trench so the flaps can be lowered, along with attaching this control horn and push rod to the servo. In addition to that, I had to mount the servo in each wing. I covered it up with white tape to make it all look nice and pretty. Now, if we look at the other wing, I got this. This is the pitot that I was talking about before. And if you look at the side of it, there's a couple of holes, and those measure the static pressure surrounding the aircraft, which is it's kind of like your atmospheric pressure. And if you look at the tip of it, there is another port, and that measures ram air. And ram air is a function of velocity, kind of. So pitot tube measures those two different pressures. It's given to the analog pressure sensor, which is located around here, and that pressure sensor converts the pressure to a dynamic pressure and analog voltage, which is then sent to the Arduino and converted to an airspeed. Arduino in turn then manipulates the servos and raises or lowers the flaps. Additionally, we have a little LCD screen up here, which shows the airspeed readout of the airspeed. Okay, so now we're looking inside of the aircraft, and I'll show you the electronics and other sensors located inside the fuselage that are responsible for deploying the flaps. So right here, we have our Arduino microcontroller. Next to it, right here, we have the Spektrum AR6100E 2.4 gigahertz receiver. All the servos and other commands are connected to that. We have a breadboard located right here with a couple of capacitors that kind of smooth out the voltage being supplied to the pressure sensor. We have a 9-volt battery right here that powers the Arduino. And that's about all that's located within the inside of the aircraft. Okay, so now I'm going to show you how the actual flaps are deployed on the aircraft. I have powered up the aircraft with the standard 11.1 volt LiPo battery that powers the servos and the motor associated with the aircraft, along with attaching the 9-volt D-cell battery that actually supplies power to the Arduino and in turn the pressure sensor. So, as you can tell, got the LCD screen lit up right here, and it doesn't seem to be appearing on the computer, but it's reading 0 miles an hour, and I'll show you how it works. So I have a manual override programmed into it, which is on this switch right here of the microcontroller, of the RC controller, and it has a manual override and an automatic mode. And based on the position of the switch, the flaps are either manually controlled or automatically controlled through the Arduino. So right now, they are being manually controlled as the flaps are in their neutral position. As you can tell, they're not being lowered. But the moment that I actually flip the switch to auto control, you can tell that the flaps here have gone down. So there you go, you can see that. And I don't have a wind tunnel here, so I'm going to have to use my mouth to blow onto the pressure, or the pitot tube. But if we simulate some airspeed, the flaps will be actuated to different levels. So that was the different speed, or different flap ranges essentially. And if we go too quick, which I'm going to simulate, the flaps will actually go up and act as an air brake. So let's try that. So that will help slow the aircraft down. Again, if I flip it to the manual override mode, both flaps will go up, and Arduino no longer controls the flaps. But if I flip them back down, Arduino controls the flaps, and since we're at a very low airspeed, 0 miles an hour, flaps are being fully deployed. So that's my project. Hope you enjoyed the video. If you have any questions about it, please let me know. I'll try to respond as soon as possible. Thanks.